We're going to talk about probability of having a couple different events happen within one roll now. So we're rolling two dice, and we want one of them to come up a 3 and one of them to come up as an even. And the key word here is "and," because that tells us mathematically what to do with the probability of a 3 and then what to do with the probability of the even. So, if we look at the correct outcomes over the possible outcomes, correct for rolling a 3 would be 1. There's 1 3 out of the 6 numbers on the die. And then possible outcomes would be 1 through 6, so 6 outcomes. When we talk about the word "and," we're actually multiplying. All right, so we're going to take the 1 6 and we're going to multiply it by the probability of the other die coming up and even. So even numbers on a die would be 2, 4, and 6. So there's 3 of them out of the 6 total. So now what we can do is multiply, and as you guys remember, when we multiply fractions, we're multiplying straight across. So we're multiplying numerators together. 1 times 3 gives us the 3, and the denominator 6 times 6 gives us the 36. And if we reduce, we can take a 3 out of both, so 3 divided by 3 is 1, and 36 divided by 3 is going to give us 12. So our theoretical probability of rolling a 3 and an even on the two dice will be 1 out of 12. Mr. Allen, should we test it out?
I think we should test it, because I love testing. Are we ready? So it's unsuccessful. I gotta have a 3 and an even. Yes.
All right, so we had incorrect. I'm writing small, I'm not sure you're going to see that. And then we have correct down here. So we had 2 correct out of 12. That's going to be 1 out of every 6 as we reduce. So the experiment gave us 1/6. The theoretical said 1/12. Again, the more samples we have, the more likely we're bringing the 1/6 closer to the 1/12.
What happens if we say or, like 3 or an even number?
I hadn't really thought about that.
You hadn't thought about that?
No, I hadn't. But here's what you do. So somebody had it written down here. It must have been Mr. Thornley while we were talking there. He's pretty quick that way.
He's good.
So again, we're looking at probability of rolling a 3 or an even. So in this case, our successful outcomes, our correct outcomes, would be either the 3 or the evens. So what we're going to do is we're going to take the probability of rolling a 3, which again we said up top was 1/6, and we're going to take the probability of rolling an even, which up top we said 3/6, and the or actually tells us to add. So if I add 1/6 plus 3/6, I'm going to get 4/6, and as we reduce that, that's going to give us 2/3. So in theory, that we should get 2 out of 3 outcomes correct.
All right. So basically, I need to roll a 3 or an even number. So my successful ones, maybe we should write this down so we remember, would be 2, 4, 6, or a 3, right? Any one of those numbers means that I win, right? Okay. And I can get that on either one of these die, correct? Boom. I got a 2. Got it, 6.
And let's look at our theoretical or our experimental probability just on that small sample would be 2 correct out of 3 total. You hit it right on the button.
Boom.